What's up guys? Welcome back to another video. To those who do not know me, my name is Lubi. You can call me Renz, you can call me Michael, basta special ka sa akin, you can call me whatever you want. I am currently 17 years old, a STEM 12 student of St. Gabriel Academy, a school that's watched me grow from a child to an adult. And as you can see, a lot has changed. But who cares about me? I know what you're here for. So, what is the content of our vlog today? We will be featuring a vlog about Newton's law of motions. You will see the first law, second law, and the third law. Of course, there will be a brief explanation for each kasi alam ko namang hindi kayo nakikinig sa mga klase nyo no? Nandito kayo para matuto. If handa na kayo, I am more than ready for you guys. Now, let's get right into the video. Before anything else, what is motion? Of course, di naman basta-basta gagawa si Isaac Newton ng isang law if he doesn't know anything about it. Like, duh, he's smart kaya. A change in the position of an object in relation to a fixed point is referred as motion. And who is Isaac Newton and what is the significance in the field of motion? Newton's laws of motion set the groundwork for today's classical mechanics. The three propositions he shared describe the relationships between the forces acting on the body and its motion, which were initially established by English mathematician and scientist Isaac Newton. So, remember everyone, motion is relative. Kita niyo, Ms. Garcia? Nakikinig ako sa inyo. Motion is relative. Why don't we see the first law of motion, the law of inertia?
Get enough. Don't ever let me be away from you. I'm gonna hold you tight, cause you're the only thing that I can't lose. I never needed you to give me things. I never needed you to.
Oh my god, that hurts. Ow. Why? See that, guys? Amazing. Hindi naman masakit yung libro at isang itlog lang talaga nasayang ko. First of all, before I explain my videos, what is the law of inertia? The law of inertia states that an object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity unless acted upon by an unbalanced force. The law of inertia applies when a person is riding their bike and suddenly hits the front brakes. Their body continues to move and then fly over the handlebars. Ouch, that hurts. Let me now discuss the first two videos in detail. Egg drop is the title of the first video. The purpose of this experiment was to simply push the plate out of the way and drop the egg into the glass of water. The egg and the cardboard tube must not be touched throughout this process. Things in motion prefer to keep going, while stationary objects want to stay still, unless an outside force acts on them according to Newton. You apply enough force to the plate to get it to zip out from beneath the cardboard tube because the egg isn't moving while it rests on top of it. The egg didn't move for a millisecond or so since it wasn't moving at all. But even though this is typical, gravity took over and pushed the egg straight down towards the Earth's center. The egg's fall was halted by the container of water, which provided a haven for the egg to stop moving and be recovered intact. The water sprang out to the egg's gravitational pull. Pages of Inertia is the title of the second video. If you're a big fan of Bill Nye the Science Guy, you probably heard about this experiment before. To begin, there's a dictionary on top of your hand, half on the tabletop and mostly in your hand. You won't feel it if you slap the book hard enough. Then repeat the process, but this time, have a friend slap it for you. It will hurt. So how does this experiment demonstrate inertia? Well, the book is after all quite large. There's a lot of inertia in it. When you slap the book, its inertia makes it difficult to move, even when moving it down. You still feel the gravity's pull and weight. However, the book's large inertia prevents it from pressing down anymore. Now we will jump right into the second law of motion, the law of acceleration.
Love you, and all the things that you do. Sounds like a fool, 'cause when you touch my hair, the words go
experiments are messy and chaotic videos that present the second law of motion. A force on an object causes it to accelerate according to Newton's second law of motion, often known as the law of force and acceleration, which states the net force equals the mass times acceleration. As a result, the object's acceleration is proportional to the force and inversely proportional to its mass. Now, in the first video for the law of acceleration, it is called "It's Raining Feathers." Well, as you can see in the video, I drop a balloon filled with water and a feather down into the ground. When an object is shown from a specific height, it is believed that the Earth's gravitational attraction aids in the development of acceleration. As the object approaches the Earth, its acceleration increases. The acceleration created by the body is directly proportional to the force according to Newton's second law of motion. The impact force is activated when the object collides with the ground. Take a Walk is the second video for this law. We're walking in this video, but it's being played fast forward, because mass is a major issue in the experiment. This video explains the law of acceleration. Because the mass of the other person, which is me, is considerably more than that of the other. It takes more force to accelerate to the same degree. One person has a lesser weight than the other when walking together. The force required decreases as the mass decreases. The more the force required, the heavier the mass. And now we are at our final law of motion, which is the law of equal and opposite forces.
I am trying to do what I am trying to do is say I love you.
In these experiments, I focus more on action and reaction forces by two objects. According to the third law of motion, every action has an equal and opposite response. In other words, the statement implies that two forces are acting on the two interacting objects in every interaction. The forces acting on the first object are equivalent to the forces acting on the second object. Action and reaction forces are the name for these two forces. Releasing air is the name of the first experiment for this law. Not that kind of air. What I mean is clean air and not the smelly one. It's extremely simple. All you have to do is blow or inflate the balloon with air. Bubulol, diba? When the balloon packed with air is released with one end untied, it releases a lot of air. A response force is created as a result of the action. Force caused by the air pouring out of the balloon, which allows the balloon to go upward or fly wherever it desires. The final experiment is known as sibling push. Don't worry, no one was injured in the making of this video. This can be accomplished by pushing each other with equal force, demonstrating the third law of motion. Forces always act in equal but opposite forces, opposite pairs. According to Newton's third law of motion. Another way of putting it is that there is an equal but opposing reaction to every action. This indicates that if you push someone heavier than you, they will push back with a force equal to the force they exerted because you are lighter. Because of the return force we experience when we push someone, we tend to back up a little or bounce from them. And that's it for the video, everyone. We show the law of inertia, the law of acceleration, and the law of equal and opposite forces, which is Newton's laws of motion. I encourage you to also try the experiments I've done as well as find other experiments to test out for these laws. This has been fun, everybody. Just don't forget to like, share, comment, and subscribe. Till then, bye!